All right, meningitis. You know it, you deal with it. But are we really as familiar with it as we think? I think this deep dive will surprise you.
I'm always up for a challenge, especially with something like meningitis, always keeping you on your toes.
Speaking of, we all know that classic triad of symptoms, right?
Mm-hmm.
Fever, stiff neck, and altered mental status.
Yeah, the textbook definition.
But get this, Microbiology says that only shows up in about half the cases.
That's a bit of a wake-up call, isn't it? It makes you realize we can't just rely on the basics.
Right. And what about those less common symptoms they highlighted, especially in kids? Leg pain, cold extremities, even weird skin color.
It's almost like meningitis tries to hide sometimes.
So let's talk meningococcal meningitis. That one moves fast, right?
Aggressive, that's for sure. And that rash.
Yeah, the petechial rash. But Microbe Canvas pointed out that it doesn't always appear.
True, especially early on. But when it does, it's a pretty clear sign. You know, that rash is actually bleeding from the capillaries in the skin.
Oh, wow. I didn't realize that's what caused it.
Yeah, the bacteria release toxins, the immune system goes haywire. It's complicated.
So even the rash is more than meets the eye.
It all comes back to looking at the whole picture, right? No single symptom tells the whole story.
Okay, so how do we diagnose meningitis with certainty?
Lumbar puncture, the gold standard. Gotta get that CSF.
And then we put on our medical microbiology hats.
Exactly.
Huh.
Analyzing the CSF, cell counts, glucose, protein. It's like solving a puzzle.
But even then, things can be tricky. I was reading Microbiology, and they said that in bacterial meningitis, you only actually see bacteria on a gram stain about 60% of the time.
Yeah, that surprised me too. Makes you think twice about relying too heavily on one test.
So even a negative gram stain doesn't mean we're in the clear.
Culture is still key. Takes longer, but it gives us a definitive answer.
And of course, then there's the whole issue of antibiotics. Microbe Canvas had a great piece about how hard it is to get antibiotics to penetrate into the meninges.
That's a huge factor, right? You can pick the perfect antibiotic, but if it can't get where it needs to go...
It's all about those pharmacokinetic properties.
Yeah. Gotta make sure it can cross that blood-brain barrier.
So does the cause of meningitis change depending on the patient's age?
Absolutely. Think about it. Group B strep. Huge problem in newborns.
Right.
But almost never seen in adults.
So different age, different bug.
Exactly. You got to adjust your thinking based on who you're treating. And don't forget, the elderly, their symptoms can be much more subtle.
It's like there's a whole separate playbook for each age group.
You could say that.
Okay.
And of course, vaccination has changed the game too.
For sure. I mean, look at the impact of the Hymas vaccine.
Huge success story. And the pneumococcal conjugate vaccine as well.
But we're not out of the woods yet, right?
I'm not even close.
Antimicrobial resistance. That's a big one. Microbe Canvas had a really interesting article about some Neisseria meningitis strains becoming resistant to penicillin.
And even some cephalosporins, which is a worry.
So it's really a moving target, isn't it? We have to stay on top of things.
Always. And that's where resources like the CDC come in. They're tracking these trends, updating guidelines.
Okay, so much to think about already. Before we get ahead of ourselves, let's just take stock. We talked about the classic triad not being so reliable, the importance of those less common symptoms,
Especially in kids.
the intricacies of CSF analysis,
And the fact that even a negative gram stain doesn't rule out bacteria,
age-specific pathogens,
vaccination successes,
and the looming threat of antimicrobial resistance.
lots to consider.
And speaking of considering, let's talk treatment. I mean, we all know the first rule of meningitis. Hit it with antibiotics fast.
Absolutely. Even before we have a confirmed diagnosis, CDC is very clear on that.
But there's an art to choosing the right antibiotic, isn't there?
You bet. Age of the patient, what bug we suspect, local resistance patterns, and then can it actually get into the CSF?
That's where our expertise as medical microbiologists really shines.
It does. We're the ones who understand the nuances of antibiotics in the context of meningitis.
So given all of that, what about prognosis? What affects how patients do in the long run?
Well, there's a world of difference between untreated bacterial meningitis.
Which is?
Almost always fatal, unfortunately. Microbiology lays that out pretty clearly.
Right.
And then you've got viral meningitis, which often just clears up on its own.
So treatment is critical.
Absolutely. But even then, mortality rates for bacterial meningitis can vary quite a bit.
I imagine it depends on the patient's age,
Yeah.
the specific bacteria.
Exactly. And how quickly we can diagnose and start treatment. And of course, there's the risk of long-term problems, especially with something like tuberculous meningitis.
That's a sobering thought.
It is, but it highlights how important our work is.
We're truly on the front lines with this disease.
We are battling a complex and potentially devastating enemy. It really is. And, it's not just about treating patients, it's about understanding how this disease is changing.
Oh, for sure. Epidemiology is key. The CDC had this report recently, some fascinating trends in there.
Like what?
Well, for instance, cases of Haemophilus influenza type B meningitis have plummeted since we got the Hub vaccine.
I mean, talk about a public health win.
Totally. And it's not just Hib. The pneumococcal conjugate vaccine is making a big difference too.
Vaccines really are game changers, aren't they? And it shows how important it is to get everyone vaccinated.
Couldn't agree more. But the fight's not over, is it? There are still challenges ahead.
Absolutely.
Antimicrobial resistance, for one. Microbe Canvas had this article, really got me thinking. Some Neisseria meningitis strains, they're becoming resistant to penicillin.
Yeah, that's a concern.
And even some cephalosporins. Makes you wonder, how do we stay ahead of the curve?
Well, we have to be on the lookout for those resistant strains. Early detection is crucial.
So we can adjust our strategies quickly.
Exactly. And of course, we have to be smart about how we use antibiotics in the first place.
Not over-prescribing.
Right. It's a balancing act, making sure patients get the treatment they need, but also being mindful of resistance.
And that's where our role as medical microbiologists is so important.
It is. We're the experts. We need to be leading the charge on responsible antibiotic use.
This whole conversation has really highlighted how many roles we play. We're not just identifying and treating infections.
Right. We're researchers, detectives,
Educators.
advocates, and sometimes, all at once, we're constantly analyzing data, interpreting information.
And communicating it all, not just to each other, but to the public too.
It's a big responsibility, but also incredibly rewarding, wouldn't you say? I mean, we're literally on the front lines of this battle against disease.
Absolutely. Armed with knowledge, technology, and a lot of passion.
That's it. And don't forget about the amazing resources we have, like Microbiology, the CDC, Microbe Canvas. They're all there to help us.
They really are. So much information at our fingertips, it's mind-blowing.
And it just shows how important it is to keep learning, to keep up with the latest research. Our patients deserve the best.
They do. Okay, before we get too carried away, let's circle back to something we mentioned earlier. The long-term effects of meningitis.
Right. It's not just about surviving the initial infection.
Some people face lasting problems, especially with certain types like tuberculous meningitis.
Things like cognitive impairment, hearing loss, seizures.
Wow, that's a lot to deal with.
It is. Meningitis can really have a long-lasting impact on people's lives.
So our job isn't just to get rid of the infection, it's to help people recover.
Completely. And that often means working with other specialists, neurologists, physical therapists, you name it.
It takes a village.
You could say that. Meningitis is such a complex disease, it really requires a team effort.
It's interesting. We've been talking about all the serious stuff, but it's also amazing to think about how resilient the human body is.
It is, isn't it? Even after something like meningitis, the body can heal, it can adapt.
And as medical microbiologists, we get to see that firsthand.
We do, and it reminds us why we do what we do. We're not just scientists, we're healers.
We're advocates for our patients, and we're dedicated to making their lives better.
Well said. It truly is a privilege to be part of this profession.
So we've covered a lot of ground today. Meningitis, it's more than just a textbook definition, isn't it?
It really is. And even for us, medical microbiologists who deal with this all the time, there's always something new to learn.
Let's recap. First, that classic triad of symptoms, not as reliable as we might think.
Right. Microbiology pointed that out, only half the cases.
And those less common symptoms, especially in kids, can't forget about those.
Definitely not. Leg pain, weird skin color. It can be tricky.
Then there's the whole CSF analysis thing. Gram stain, it's useful, but...
Only 60% of the time you actually see bacteria. Culture is still the gold standard.
And of course, age matters. Different bugs for different age groups. Group B strep, for example.
A classic example. Newborns, yes. Adults, almost never.
And speaking of changing things up, vaccines have been a huge success.
Oh, absolutely. Hib vaccine, pneumococcal conjugate vaccine.
Yeah.
Amazing how much they've reduced the number of cases.
But antimicrobial resistance, that's a whole other story.
A big one.
Until next time, stay curious.